We're going to briefly talk about permutations. Oh, nice. And then we're going to talk about identical items and how that affects this. So our permutation can be written with n being the total number of values in a set by the permutation r, which is the number of items we want to use in the set. Okay, so if we had a set of 5 total numbers, and let's say, or 5 letters, say we just had A, B, C, D, and E, and they wanted to know how many different ways we could put the order of maybe like A, B, and C, 3 of those terms. That would be kind of like a 5 with a P3. We're only taking 3 out of the total number set. But in the questions we're doing with identical items, they're asking us questions like, how many different ways can we rearrange the word and, the letters in the word and? Well, there's 1, 2, 3 letters in and there's a total number of 1, 2, 3 letters in the set. So the set n being 3, and the numbers in the set are also 3 in this case. They want us to use all 3 letters. So in which case we have 3p3, which is going to give us a value of 6 when we put it into our calculator. Okay. Now, in another question, they've given us, how about in the word all? A-L-L. Okay, well, there's 1, 2, 3 terms in this set, right? And we're going to use all 3 numbers. So again, we're using a 3p3. So this is the total number of terms. But the problem is we have 2 identical terms, L and L. Okay, so because we have L and L, we have to set this up where the way we do it with identical terms is we do the total number, so total number of possibilities, the T's, and we divide that by the total number of redundancies, you could say, or how many different ways can we arrange the 2 other letters that are identical. So number of identical arrangements, number of identical arrangements. So what does that mean? Well, the total number of possibilities is still our 3p3, okay? So we still have 3p3. But the number of identical arrangements, well, we have 2 letters, and how many different ways can we arrange those 2 letters? Well, that would be a 2p2. We're going to divide those 2 terms. Well, 3p3 is going to give us 6. And our 2p2, I think.
2.
Yeah, it should be 2, right? Yeah. 2p2 is going to give us 2. So the total number of ways we can arrange the word all are 3. And if we try to logically think about this, well, how can we arrange all? Well, we can go A-L-L, I can go L-A-L, and I can go A-L-L. Let's say this is L1, L2, L1, L2, L1, L2. Well, what if I went A-L-L, L2, L1? In the way we're using the letters, yeah, they're different, but really that's still the word all.
The last one, I think you meant to do LL.
Oh, sorry, I did. I didn't mean to go LLA. Thank you. LLA. Yeah. Okay. So do you see how that still makes the word all, so it's a redundancy? Okay. So let's say another example of this would be they do the word doll. Doll is a good one. So we have the word doll. Okay. Well, I have 1, 2, 3, 4 terms, and that's going to be our n. And how many terms are we going to be using out of this? Well, we're going to be using 1, 2, 3, 4. It's not like we're only using DOL of doll, right? So that's going to be our R. So our permutation on top, this is the total number of possibilities. So total number is equal to 4p4 divided by redundancies. Well, how many redundancies can we have? You can only have 2. There's only 2 letters that are redundant, right? And that makes it a 2p2 on the bottom, We already know 2p2 is 2. 4p4, maybe 24. 4 is 24. So the total number of ways we can rearrange the letters in dull, or dull, is 12. Okay? What about, they did another one in an example. They said L-O-L-L. Okay, well again we have 1, 2, 3, 4 total letters here. So for our total number, we're going to have 4p4. That's the total possibilities if this was like L1, L2, and L3. But the problem is those are all identical letters. How many identical letters do we have?
3p.
We have 3. Yeah, we have 3p3. So 3p3, which really cuts down on our values. That gives us 24 divided by 6.
Yes.
Yeah, so that means we can rearrange this 4 different ways. And really 4 different ways, you think about it, that's O starting at the beginning. So O-L-L-L, L-O-L-L, L-L-O-L, and finally L-L-L-O. Those are the only real 4 possibilities because all of those L's are redundant to each other. Okay? So that's how we deal with identical terms. We divide to permutation.